So, the structure of atoms. Nucleus, composed of protons and neutrons. Size of the nucleus, 10 to minus 15 meter. Size of the atom, 10 to minus 10. Is this almost 100,000 times larger than the nucleus? So at the time, scientists said, oh wow, the universe is full of emptiness. Electrons at far distance, nucleus in center. But later on, we found out that electrons are not really a particle orbiting at this distance. They are everywhere. They are scattered everywhere in this space. We'll talk about that. That's called quantum mechanics. Okay. So guys, now we show an element with a symbol. Atomic number is coming above the table, and atomic number shows number of protons. So guys, look at the periodic table. What is atomic number of carbon? How many protons in carbon? 6 is correct. Do you see the number on the top? The symbol is C, yes? Carbon, right here. What is the number on the top? 6. That's atomic number, so 6 protons. And atomic number of lithium is 3. What does it mean? It means it has got 3 protons and 3 electrons. How many neutrons? We don't know. Neutrons depends on the mass number. And if I look at the subatomic particles, protons positive charge, electrons negative charge, neutrons are neutral. So these are the subatomic particles. Protons with positive charge. Neutrons, no charge. The mass is almost the same as protons. Electrons have such a tiny mass. They are 2,000 times smaller than protons. So really, mass of atom is mass of nucleus. Electrons have almost 0 charge. Okay. So guys, go ahead. One team and 2 and 3 and 4, 5, 6, 7. Oh, you all got it. Good job. Yes or no? Thank you. Yes. Yes.
So do electrons shells? Are they all separate, or do they like entangle with each other? Like
No, they are separate. Energy-wise, they are separate.
Oh.
Yes. And there are certain energy levels that can be occupied. It says energy is quantized in atoms. If you apply energy to atoms, electrons are going to be higher energy. But if the package of energy you are giving is smaller than the difference between the two levels, energy is not going to be absorbed. What's your name? Riley. Good question. What's your major? Okay. Seem to know more than you're supposed to know for this course. Good job. Are you watching Discovery Channel? How do you get that information? Yes. Okay. Yeah, you're good at science. I can tell. All right, guys. Can I say number of protons and electrons are equal together? Because they have same charge but opposite. Yeah. An atom is supposed to be neutral, right? So if I give you atomic number, which is number of protons, you already know number of electrons. Yes? Okay. So if I say hydrogen, which is shown by symbol H, atomic number is 1, therefore it has got 1 proton, it has got 1 electron and 0 neutron. And mass number is 1. Atomic mass, we are going to say atomic mass is 1 because it has 1 proton. Mass of 1 proton is called 1 atomic mass unit. So 1 AMU is the mass. Nitrogen, atomic number 7. The mass number is 14. If there is 7 protons, there must be 7 neutrons. They must add up to be 14. Number of electrons the same as number of protons. Let me write this on the board. Some of you are giving me threatening looks. So I better write this on the board. Guys, if I say iron with mass number 56, iron, mass number 56. If we are talking about iron 56, what is atomic number of iron? Go ahead, look it up on the table. Give me atomic number. Atomic number for iron. 26, yes? This is called atomic number, the lower left number, atomic number. This is called mass number. Mass number shows number of protons and neutrons. Atomic number shows number of protons. If I want to decide number of neutrons, I have to write 56 minus 26. Does this make sense? So you need mass number and atomic number to determine number of neutrons. Guys, if I say hydrogen, hydrogen 1, atomic number of 1. How many protons? 1 proton. How many neutrons? 0 neutrons. How many electrons? 1 electron. What if I say hydrogen 2? This is hydrogen as well. It's just a different atom of hydrogen. How many protons? Yes. So 1 proton. How many neutrons? 1 neutrons. How many electrons? 1 electron. What if I say hydrogen 3? What's the difference? How many protons? How many neutrons?
2.
How many electrons?
1.
Yes, no, 1. 1 is correct. I was wrong. So what do we call these different atoms of the same element which are only different by their number of neutrons? Yes! So many of you said it. Good job. I like that. Isotopes, these are isotopes of hydrogen. So isotopes are different atoms of the same element with different number of neutrons. Okay. So if I want to show atomic symbol, mass number appears on the top, atomic number appears on the bottom left. Top left, mass number, bottom left, atomic number, the difference shows number of neutrons. Yes? Does that make sense? Do you have any question? You're doing very well. I know you're tired, but you're paying attention. Thank you for doing that. Mamisha, right? Maisha. One of these days I'll learn. Yes, Teresa.
On the first one, was there a reason that you switched like the bottom and like, is the 26 there is on top?
Yes.
Is there, what was your reason for that?
Okay, guys. Teresa is asking, how come using the table, atomic number is appearing on the top? But when I'm showing symbols of iron, I show atomic number on bottom left, Top shows the mass number. Because if I have 3 hydrogens here, do you see I have 3 hydrogens here? Really, the table shows 1 place for hydrogen. So how do I get the mass of hydrogen when I have 3 different hydrogens? I get weighted average of all of these for hydrogen. So different conventions. The number appears underneath the hydrogen is showing mass of an average atom of hydrogen. But when I'm talking about special elements, the special isotope, the convention is different. Yes, 2 different conventions, and it is confusing. Atomic number appears above the element in table, but I'm showing a specific symbol for a specific isotope appears on the bottom left. Mass number does not appear in periodic table because mass depends on which isotope I'm talking about. So the number you see is atomic mass is average of all different isotopes and their different percentage. Good point. Yes, they are different. So guys, go guys, together help each other with your team. See if you can answer this question. I think you can. I bet you can. Some teams are very interactive. Some teams are not talking together. They are not helping each other. Get your partners involved. You shouldn't have any silent partners. 1 team and 2, thank you. And 3 and 4 and 5 and 6, yes. 7, yes, doing well today, Marina. 8, 9 team, 10, yes. That's Sharon's team. Yes, that's Liz. Liz team, yes. Yes, that's Matt's team. That's Neil's team. Yes. What's your name? Brandon. Brandon or Brandon? Brandon, thank you. And that's it. Guys, does this make sense? Yes? Are we almost there? You want to do one more? Go. Do this one. Yes, that's it. Is your team with you, Dit? Do they talk to you? Make them talk. Help them. Make sure everybody is involved. Thank you. All right. Thank you. 1 team. Holly. Thank you. Holly's team. This team, that's 2 teams. Yes. Jessica. Sadie, of course, Sadie. I know you. I have been knowing you forever. Previous lives. 4, 5, 6. I need more show of hands. Yes, 7, 8. 8 teams, 9 teams. I need more show of hands. Help each other. Make sure everybody is with you in your team. Does this make sense? Have a wonderful day, guys. Thank you.